Great. So with that being said, I'm giving a stage to Kostiantyn Vesna. I'm super happy to have him over. He's been working as a staff engineer at Google, and he has great experience on building big systems and advanced architecture, and he's gonna share how to use coding agents properly. Not
properly.
But I kind of like want to use this as an opportunity to kind of maybe build some best practices or kind of learn what was working, and kind of hope we all kind of get a little bit better of understanding of how where we can and where you cannot rely. For example, like the memory is one place where we cannot rely on agents. And I discovered the hard way that you cannot allow to build even seamlessly simple production systems with LLM. So I kind of hope that Kostiantyn will share us some his insights. So please welcome Kostiantyn.
Thank you. Hi, everyone. Can you hear me well? All right. So currently, I am a solo developer, founder, CEO, if you will, of a Hyperdraw, a one-person startup. It's very easy to have so many titles. And I will talk how to build complex software system with AI agents. I think most of you are trying to do something like that today. So that's my actual photo. I work with those hands, with the code. They're very clean. I use AI to write AI. And you hear from any type of podcast, from YouTube, you open the internet and you hear AI, AI, AI. You're going to be replaced in 12 months. You need to buy Cloud Code. You need to buy more tokens. You need to not buy more tokens. You need to use OpenClaw, NanoClaw, whatever. The thing works, right? We all know it works. We have seen it. So for myself personally, I have merged 100 PRs in the last 2 months. 2/3 are cloud agents. 1/3 is local agent. 0 PRs, full manual. And yet, not all of the AI output is equal. For example, every time I try anything that is not Claude Opus, I go back to Claude Opus. Yes, even with Claude Opus, some PRs go so easy. Just one shot, everything is clean, you merge it, happy. Other stuff, you have to check in locally, fix, good enough. Some stuff you just have to close the PR because it went completely sideways. Why? Why does it happen? Why some tasks that seemingly look harder take actually less time, and something supposedly trivial doesn't want to work? And the answer is statistically, regression to the mean. Those models have been trained on the entire internet. They know everything about the code. They know some very good code and some very bad code. And if we trigger the model to go into, let's not use slurs here, but let's say there are many developers who maybe could have found a better career in other industries, right? And that code was in the training set. Anyway, so models are genuinely good. 4.5 was already scary good. 4.6 is a beast. It can do literally any language, any crazy tasks, but you need to push it. You need to push it to make it do the stuff that you want. And everybody has superpowers. Everyone in this room has superpowers, and about 30 million people who downloaded Claude extension for Visual Studio Code also have superpowers. There's a lot of competitors. So remember, if you remember, one thing from this talk, the tool is not your moat. You are your moat. You get better, you stay in this industry. You don't get better, Robots will replace us, yes. So with the higher speed, we get, resistance of the environment. We get drag if you go too much into the physics. As we add more features, each of those features add a potential surface area for bugs. They add the need to test them. When you code one feature, you're not coding another feature. And this nice little gentleman on the photo who is very efficiently cutting butter, with high-powered chainsaw. The fact that you can do something doesn't mean you should. Complexity. This is the only slide like this, I promise. And it doesn't blink. I was tempting to make it blink. Complexity did not go away. The software is a fractal. The deeper you go, the more complex it gets. And the thing about complexity, that it gets exponentially large as you zoom in further. You want to make a website? Okay, it's easy. You want to make a website with infinite scroll? Sure. With a high-performance infinite scroll. With a high-performance infinite scroll that has 1 million items and also remembers the scroll indicator. Make it 3D, right? The deeper you go, the harder it gets. And all of these people, they want to replace programmers, and they tell how like anybody can just go and ask AI and do it. You've seen this movie, Wishmaster, or maybe Monkey Paw, stuff like that. You just ask some magical power to grant you a wish, and it grants you the wish kind of how you said it, right? It's just never how you want it. So what those people on that list, what are they saying? Turing, what did Turing say? He said, you cannot know how long the code will take to execute unless you execute it in a general case. Perfect. LLMs are function approximators. That's functional programming. That's code. It means you don't know how much it will take Claude to work on your ticket. You just don't. My amazing startup that I am, pushing PRs out, it still has 0 customers, and it eats my money. It doesn't earn me money, right? That's Darwin. It says survival of the fittest is the fact that you can produce so much code doesn't mean you produce something that market needs. Doesn't mean you produce something that people are willing to pay money for. And that's never going to change, right? There will always be competition. We're going to get to Amdahl in a second, but Dunning-Kruger, not the least important, when people just start doing something and they feel this new power and they feel like they got it, they are the experts. It turns out that's not always the case. So Amdahl, we heard agent swarms, right? We're gonna have 4 agents, in terminals. But why stop at 4? Make it 1,000, Just legions of agents, my own army of robots who is gonna dominate the world, right? A simple mental exercise. Just ask that army of robots to write you an algorithmic trading bot to go to Wall Street. Is not so far from here, and just make you rich, right? Why not? A silence. Nobody even laughs at it because it's not gonna work, right? The thing is, I jumped a little bit, but with parallel agents, the problem is that merging the code itself is a list of your problems. When you have different agents doing different parts of the work, they might override each other. They might conflict in the very intention they're doing. They would make a front end that looks different, yeah, there are different colors, or they might pick a different programming language or a paradigm. And all of that stuff, it requires serialization. And serialization is a limit to any type of parallelization. So yes, the bottleneck has moved. You open any type of AI video, any type of webinar, you ask ChatGPT, they're telling you bottleneck has moved. And we can summarize, yeah, the stage 2 from South Park, right before we get the profit. Nobody knows the answer. That's the thing. But what we know is that now, with all of these superpowers, it's not possible to hide inside of the niche and be, a single developer at your company or in the world who decided to do something that nobody else cared to do. Now Google can just do that one as well. They can go for the long tails. So anyway, it was so much darkness. I want to bring us back to, to the hope. So why does AI not work sometimes? Why it doesn't work? It doesn't work because we do not create the infrastructure for AI to work. This amazing Formula One, right, is stuck in the dirt because we didn't build a highway. And in this new world where robots are so fast, where AI can write the codes and tests and everything, our role is to design the high-speed roads for our new robot overlords to write the code without a hitch. So you need to design those clean lanes for the agents. That way, your parallel agents, I don't know if you can make it 1,000, yeah, but half a dozen, maybe more, at least they can work without stepping on each other's toes. Once you understand that this module is isolated, that one is independent, right? And then you can evolve them in parallel. And that means that now you get a little bit of ease from the tyranny of Amdahl's law. SDLC, so software development lifecycle. Everything you've heard on agile trainings, all of these books on how you're supposed to write your code, that stuff still matters. That stuff is more achievable now. And it actually becomes mandatory. So Vlad mentioned I spent some time of my career at Google. Google had this problem much earlier just because they have so many developers. So we are talking 100,000 engineers pushing the code in the same monorepo. And what does it mean? Is that you have a gigantic stream of those competing PRs, essentially. And that is what everyone will have today with AI, because AI keeps generating those code artifacts. And so what happens that if you're still not using version control system, I don't know what you're doing, but the thing why Claude Code is so efficient, and I don't know, AI for lawyers, AI for doctors is still only talks, because we can revert. We can test in isolation. We have 50 years of TDD. We have 20 years of containers. Like all of that stuff came here, and then with AI, now we have the high-speed road for AI to move. So Yeah, I'm saying feedback latency dominates AI coding productivity. Yes. Tests. So without tests, AI coding is just high-speed vandalism. AI gonna not remember. We just had a talk about memory, right? AI not gonna remember what the same AI did 5 minutes ago because it's not the same AI. It's instances, right? All of those clones, they are not a person. They don't have this shared memory. So you ask it to do one thing, it focuses and does one thing. You ask it another, it does the second one. But the only way you can preserve what you have built is by creating tests around it. I use this metaphor of corals. I don't know if you like tropical countries, but coral is this live, polyp thing, very soft. It grows inside of this ossified, calcified tube, almost like a rock. That's what we know as coral reefs, right? So essentially, you have those like a small jelly building islands. And so we kind of need to make AI do the same. It can write the code, you test it, you like it, and you say, okay, now cover it with tests. Cover it with tests. You can go drink a coffee meanwhile or manage more agents. Yeah, and as the time goes, you get this island of regression tests. Yeah, that the code that maintains itself. Who checks the checker? Yeah, so spec-driven development. Who here have heard the term? I see hands rising up. So basically, the idea is next. You write, AI writes the code. AI also writes the tests. So how do you test the tests? And the people are like, yeah, we're gonna do specs. We're gonna do spec-driven development. So you just define what you want, and then AI works from here. But how do you check it? And the problem with specs, because I've been trying to do it for like almost a year now with those specs. Basically, the spec is usually so dense, it doesn't have any room for maneuver. It's like every sentence is very meaningful. So when you try to load a big spec, let's say 800 lines of text inside of Claude, it doesn't really remember it. It struggles. And what you can do, little cheat, little hack, you can do what ISO is doing, what W3C is doing. At least put indexed numbers, like a section 3.6.7. So then you can talk with your Claude not about the entire spec, like, hey, go read the spec. No, go read that section and write the entire test file, 20 tests just for that one section. And then it actually works quite well. Context. Context is a real resource, yes. 192,000 tokens. Supposedly that's a lot. As you probably know, 30% of that is reserved for output, so you actually don't even have 192. Needle in a haystack, right? What about needle in a needle stack? What if you need to find a lot of stuff? So I don't want to bore you with all of this researches, but basically, if you actually try to prod how much recall the LLM has from the stuff that is inside of its context, it's very far from perfect, very far. And that's normal, because if you think about it, LLM is like, we think of it as a normal text, as if human wrote it. Yeah, but no, it's like thinking. So if I would give you, I don't know, 10 texts and ask you to recall, right? You're not going to be able to answer, because it would just like stroboscope your brain. Anyway, I'll stop here. Don't want to distract. So architecture. Architecture is still the king. What you want to do is you want to make sure that the code base that you maintain is in the shape that allows AI work there productively. You want to use the power of the LLM on that one bug that you are solving today. You don't want to distract it. You don't want to say, hey, also do this. No, just focus the entire power on that one thing. If it's refactoring, okay, do it refactoring. If it's a bug, fix a bug. New feature, no problem. So here is my secret. Maybe it's gonna be expired in a couple of months, but this is what I actually do. So defining the intent is, you have to keep the agency on you. You are the only person who knows what AI should write, like, and why. So you need to define for yourself, what do you actually want? Talk to ChatGPT and talk to humans, like research, understand what is it that you are making. Then make AI draft a spec. Read it. Does it match with what you have been thinking in your head? Or it's like completely bananas, or it misunderstood you, right? Like that's your way to kind of avoid costly mistakes later. So once you're happy with it, make AI do the gap analysis. Just go to your GitHub, launch a cloud agent, don't even look at it. Just tell him, do a research, conduct a research on my code base, check this spec, check the current state of the code base, and see how far are we from achieving it. You would be surprised. Sometimes it gives you really, really nice optimistic results, which are good because you are already close, because you are working to it. And sometimes it will be like, oh, well, it's a lot of work ahead. Then when you're ready, implement against the tests. Yes, I'm saying TDD, like fundamentally style TDD. You ask AI to write the tests, the failing tests, before writing the code. It's terrible if you're a human. It's like, it's soul crushing. But AI doesn't feel pain. So you can ask it to, right? So once you do it, verify, the neighborhood. It's like, okay, this feature works, but what about everything else around it? So I make like a drawing application. So there's a tool, free transform. It has gave me a lot of headache. I add a feature there, and then I see how it interacts with other tools. And sometimes this interaction breaks, right? So you need to detect them and then come back to AI and ask to fix those bugs, right? And finally, you want some cooldown. You want all of these important features to kind of stay there, cool down. Maybe don't ship a new features or a new major refactoring in the same place you are still worried, right? And then if you see like it seems like it's fine, then okay, you can like reopen that track, if you will. Yeah, speak the language. So things have happened before. There has been different type of scientific, industrial revolutions. Back 500 years ago, people were worried that peasants would read, much less write. Yeah, like what would they write? And I'm from Ukraine, so there is like this cool history. Ivan Fedorov was the guy who made the first printing press in Moscow. Supposedly could have been a cool guy there, but apparently the guys who were writing the books manually, they didn't like him. They wanted to put him like on a stake, very literally. So he ran away to what later became Ukraine and became the first Ukrainian book. Yeah. So let's not listen to people who are, telling that we need to still write the code by hand, that AI is wrong. Let's lean onto the capabilities of the new tools and extract the most out of it. It's literally the typewriter has disappeared, but your brain has become more important than it ever was. And just one more last passing statement. This AI was trained on the entire human knowledge. So in order to get it to do the things properly, you need to speak in the language of that human knowledge. So either you become an expert and you use that jargon, or you give the tool to the real experts, people who have been doing it their entire life, right? So you can choose either you kind of get closer to there, or you become like infrastructure provider, yeah? And you just let people do self-service. And with this, I want to say, we are all learning, and I really want to hear from you. What did you learn by doing very similar things with very similar tools? Thank you so much.
Thanks, Konstantin. That was very helpful, and I think I am kind of agree. But most of you say like something is like new to me, but I'm kind of curious to out of hand. So let's just dive into that one.
Hi, thank you very much for your talk and for so many crucial topics that you've highlighted. And one of these, the thing that I'm interested in, that you said that the version control is one of the most important thing because you need to be able to roll back and just don't make the mess with your code. But I think that the very interesting aspect of the version control is what is a unit of version control? Because back in the days, we were controlling over the assembler commands, but then we started to believe compilers that translate our high-level code, on high-level languages code, into these assembler commands, and we started to version control the line of codes in a high-level languages. And now we are entering the era when there might be the transition from the version controlling of the code to prompts, or maybe version controlling the flow of the prompts that that bring this code to life. Because now we are still controlling the lines of the codes, and when you constantly working with some code base by your own, you are familiar with this code base. But when you are working with this code base through the AI, you are not familiar with this code base. And if you are still controlling the lines of codes as in your version control, it might be the wrong unit.
This is a great, can you hear me? Yeah, so this is a great question, a great topic. And when did people stop checking in assembler and just started in checking in, C or C++, right? When you get deterministic high-quality generation of the lower-level artifact. So when we know for sure that regeneration of the artifact would produce, at least as good, then we don't care about the low-level artifact. So today, if you save the prompt, I don't know, Claude, write me a clone of Airbnb, right? We probably cannot rely that it will replicate the same result if you try it again. So code, like the software 1.0, is still valuable as it is. may it become obsolete? I think yes, but like gradually and eventually. One thing about prompts is that they are this one-dimensional sequential textual language, right? That's very similar to what all of the other programming languages are. And in a way, I expect, prompts to become more like software 1.0. Just like, if you read some lawyer's text, it's English, supposedly, right? But it's a very special type of English. So I think, but yeah, like storing prompts, why not? And more questions, please.
It's not really a question. It's it's a comment on this, and I think we're moving into this direction. And the spec is going to be the new code if it's written properly, and I cannot hold back the possibility to recommend my friend. The creator of Kotlin language is now developing a new language. It's called CodeSpeak. It's basically what you're describing. So ability to write reliable spec and then version the reliable spec and generate predictable code from it.
Thank you. I can get a question from the back. Anyone?
I thank you for your great, right here, the poll is in the middle. Thank you for the great presentation. I think it was on slide 12 that you were mentioning something about review the plan, read it, and think about it, or maybe a little forward. Sorry about that. But you mentioned review, read it, and make sure that you validate like you're okay with it before you deploy the code, right? I totally agree with that. However, how does that fit into this modern pressure of having to deliver things in this ultra fast speed that sometimes stakeholders and leaderships expect on us as developers? And then moreover, as how does that reflect on how we're seeing so many incidents happening in cloud providers of things that are known information that leaks and say, oh, it was an AI code that generated an issue and this data center went down, etc. Maybe because someone didn't have a chance or was pressured to deliver something fast and didn't stop to read and think about it. I just want to hear your thoughts about that.
Yeah. So I would try to stay within, social acceptable metaphors. I learned to drive maybe like 2 years ago, and I did it. If you are pedestrian, you can walk like whatever the hell you want, right? You can stop in the middle of the street. You can walk on the red. Like you can go faster, slower, walk around people. You don't need any rules, and you don't need license to be a pedestrian, right? Once you get faster, once you get heavier car, you get like more and more involved licenses, right? Because you can hurt people. People can die. So with AI, being able to produce all of that code really fast, like, okay, that's great. But now, for example, you're making a billing system, yeah? You made a billing system in 1 hour. That's amazing. Next day, your money is my money. Is that still amazing or not? Do you want to maybe talk with, with people, give it another day, think about it, right? So that your money stay your money, right? Basically, I think we will need to wait a little bit for, for managerial culture to adapt. Right. If you can, doesn't mean you should. Yeah, hope I answered the question.
I also can partially answer to the question is, I agree that it's mostly comes down to communicating with your stakeholders about what is achievable. And also a lot of that pressure that kind of gets down on the developers recently about like ship like a 10 times more, 10 times faster comes from those advertising and proposition about the value. But I guess it's, as a developers, we know that it's not the case. And I think the more time passes, the more use cases we have to communicate with stakeholders. For example, like some recent outages with Amazon might be a good example. So it's kind of the continuous open conversation with the management stakeholders. That's now on us developers. So.
Thank you. Great presentation. I agree with all of you said. And I was just wondering your thinking about the diagrams. Recently, I discovered that actually UML is a big thing right now, because when I develop something, I ask like Claude or any other LLM to like, all right, draw me a diagram. So I want to see how you understood it. And in a lot of cases, it's wrong. Not because of LLM, of course, because of my prompts, etc. And I'm just curious about your comments on that.
So Claude, I would say for at least half a year, but especially like 4.5, 4.6, it's quite good with diagrams. It can make like a mermaid diagrams, UML diagrams, just like AI art, like pretty decent. So yeah, use it. Why not?
Thank you.
Yes, and you can actually use it both ways. You can just draw something on a whiteboard or or a paper and show it to Claude, and it actually understands.
I have a relatively quick question. You're so passionate about writing tons of code yourself, and you've played around with context windows and stuff. Any first-hand experience with trying to make it speak faster, like this caveman language, use fewer words? Just, if you have anything first-hand, that would be awesome.
Yeah, so the joke is about the caveman language. You've probably seen it on Twitter. You make AI speak like, like one sentence words or one word sentences, and you save on tokens. Similar joke is using Mandarin because, shorter words. That is actually true to some extent, but the superpower, the cheat is symbols. So what is symbol? It's a token with such a heavy weight that it immediately teleports LLM or diffusion model to a special basin. It's like the area where that stuff lives. So I use method acting, like literally, catch me if you can, pretending I know what I'm doing. I use words from the industry when I'm, for example, debugging WebGL. I don't know WebGL that well, but I use the 3D lingo, and he's like, oh yeah, okay, I'm gonna do it. Or I say like, hey, think about C++, just write it in JavaScript for simplicity, but think in C++, right? And then it gets to all of these books that it have read, to all of these repositories that it have seen, in that kind of native language with native lingo. One more, and then maybe we can just have open discussion.
You talked about the kind of old things that are really valuable. Like for one, our previous speaker was talking about structured data, right? And also we have like certain principles like solid. I'm wondering to hear about your input of like, what are some of these important principles we had in the past, which could help build us this highway you talk about, where these AIs operate in a certain lane where they can be faster, So
short answer, all of the above. Like, yes, solid actually helps you. I'm not gonna explain why, but TDD really helps you. Small revertible PRs help you. CI/CD is super crucial. If you are, basically all of that stuff that was considered best practices, it is best practices. And with AI, we can actually afford it now. Because with tests, for example, if you need to spend 2 weeks writing tests for some code that maybe nobody even uses, right? You're not gonna do it. You are a reasonable, agent. But AI can do it in half an hour. You can even go like, if you are like on a time budget, you test the PR manually, right? You're like, okay, I swear it works. You merge it, that's it. And then just create, cloud job, cover it with tests, right? That's it.
I think I can take another question.
Thank you. So I just want to know your opinion about this idea. Some people is afraid that AI is going to cut jobs, but I was thinking about it, and I think that the companies that goes that way and fire people, they are going, to have the same productivity with less money, with less people, but they are going to be left behind by the companies that keep the same people and increase productivity, like shorter time to market, more products. So do you think that actually it's going to be like that, like the job market remains the same or even increases?
So I think job market is not going to remain the same. That's a fact. It's changing. There will be layoffs. There are layoffs. There will be bad managers who would justify their own, incompetence or literally embezzlement, right, by firing programmers because of AI. But if you think about it, like, what is a person? What is a human who choose to become a programmer? Yeah, it's a very specific type of mindset. And I will again bring lawyers as example. In theory, anybody who speaks a language like English, can be a lawyer. Just go to the court, talk to the judge, tell him you're right. Yeah. Why are you laughing? I don't know. Same with programmers, that patience to sit and check all of the edge cases, that kind of pressing need, like you feel like it seems like it's working, but you are not sure it's working. You think you missed a bug somewhere, right? And you are on a family dinner and you're thinking about that bug, right? Like, the type of person will still be needed. And the problems didn't disappear. AI lets you write so much more complex software. Like, it can do a website. Who cares about websites? People will want, 3D websites. Like, we will all be learning distributed algorithms very soon. Because yes, when everything easy is solved, then we go to the hard tasks, and hard tasks will still be hard. So I think, there will still be jobs. Thank you.
Sure.
Thank you so much.
Thanks, Konstantin. I guess I may have the last question, maybe. The first is, I also truly believe that the spec-driven development is not the final stage, and where the AI coding or AI driven development leads us is to the more like higher level programming language, which specs itself become a programming language. And the problem with the natural language is that, and why we have like mathematical language or the coding as a special case, is that it's not unambiguous. There is always an exact resolution. And natural language is not, and it's by design. That's why we have this part of social.
I think I can answer it with, I don't remember who said it, but the quote is, all of the models are wrong, but some are useful.
Yeah.
So Earth, it can be modeled as a sphere, right? But then you're like, well, it's square sphere, and then like a tilted sphere. And then there is like a mountains. And then when you start exploring, there is so much details to what is the actual shape of the Earth. So when we have, I don't know, build me a clone of the Uber, it's like, okay, what exactly do you mean? Well, like everything we specify, there is always room for interpretation. And the thing is that no matter how good spec you write, there is some details underneath that needs to be defined. And it turns out at some point, declarative and imperative, they are like, people were joking that HTML is not a language, right? But it's declarative,
Yeah. I also like to bring story, not I'm also like not doomed about that developers gonna go away. I think for me, it looks like more like a story that happened with Photoshop when Adobe first released the Photoshop, and a lot of people were also kind of doomed that the creative jobs and people who are drawing will kind of be wiped out from the market, and there is going to be anyone can do their kind of creative work, but it turns out to be quite opposite. Their market itself exploded, and it's more. And the main thing that it created, the more people that kind of in a creative field to appeared. So I think the similar and the same is like the website framework, like the whole web dev before the frameworks, and like and then you just need to write CSS.
I think we will get like 1 billion of programmers, and people will be programming some stuff that maybe exists for like an hour. Like you can program your coffee machine or something with your voice, right? And that would be normal.
Yeah, and I'm completely agree with those all 6 points in terms of I found myself spending way more time working in a plain mode and building the specs and then kind of iterating about the specs itself. Probably like 95% of the time I spent just kind of working with specs. And if you think about it, it kind of means that it requires you to understand the whole code base, like the project itself, very deeply. Not necessarily at the language that is defined, like the programming language, but at the architecture level, which kind of goes back to one of your points that you need to know the architecture and kind of you still, in terms of like an amount of cognitive load, it's still the same amount, like even as before using the code base, the code agents. So it doesn't give you a shortcut actually that much. It's more like it's gives you accelerate in very particular things, but you need to be very, very careful about
it's like a multiplier.
Yeah.
So if you have negative input, it multiplies negatively.
Yeah. So for me, it doesn't, the AI structurally does not change the way systems get built. And that's why as developers, engineers, we can still be here. Oh, thank you. I think with that, we'll conclude our official part. We're gonna still hang out here for another 20 minutes, so and until like 8:10, and then we'll meet you guys who want to stick around for a little bit and in the Old Town Bar. Otherwise, we'll see you next month. Thanks.